Hi, good morning, everyone. Hope we can see all of us. It's a great day. Just to give an introduction today, very happy to launch a series of sessions in the NLP area, especially inviting some of the best and the leading minds in the industry like Vivek Anandapani, who is the co-founder of Reverie Language Technologies Inc. And thankful for the team at Reverie for organizing this and enabling these great sessions. And just to give a brief, I won't take much time, a few minutes of introduction, and then I will hand over to Vivek. I am Krishna Prabhu, KP, and I lead the technology aspects of data science and artificial intelligence at NASCOM Center of Excellence. And to give a brief of what these sessions and the series of workshops are all about, India, as you are aware, we have 23 different official languages and thousands of dialects spoken across India. So if you think about natural language processing, India is the epicenter of NLP, which no one can deny across the world. But we have seen in the past that the technology companies are from the innovators. So there is not much of an adoption, especially in the core software areas, which form the building blocks or the fundamental building blocks of the applications which sit on top of them. All right. This, in spite of there being a huge social advantage in integrating this NLP languages across India, not only that, but also there is a huge commercial aspect also, which is an advantage for the people who are rightly leveraging those aspects. So I think the time is ripe for us to bridge this gap in both these aspects. I am very grateful for people like Vivek who have pioneered and been at the forefront of innovation in this area, because most of the impact is, as we can say, is in the social side rather than on the commercial aspects. So, of course, to give a very brief introduction of Vivek, Vivek comes with a research background from CDAC, which is a premier research organization in India, and has been deeply involved with the development of NLP-related technologies, specifically focusing on Indian languages. Of course, we have come across NLP in multiple areas, but those focus on languages like, say, English and other foreign languages, which are not very much uh, not very much to the advantage of India, where we are facing this acute problem per se. So, of course, Vivek is also a co-founder of Reverie Language Technologies Inc., which is, we can say proudly, that as the forefront of NLP in Indic languages. So I leave the rest of the things to be handled by Vivek at this stage. Let us listen to Vivek to set the context for the upcoming sessions, as well as walk us through the landscape of NLP as well as innovation in India. Over to you, Vivek.
Thank you so much, KP. Very good morning to you all. You have all, basically joined here today morning, and I do hope that we have a session that is useful and you are all able to take meaningful stuff away from today. So let me give a very short brief about my experience with Indian language computing, and then we will jump into the session details. So I basically was not educated or not trained in computing. My stream in professional studies was instrumentation engineering. But computer fascinated me when I was initially getting into the computer lab in our engineering college. And I was interested to do something in programming. And those were the days when multimedia, internet were the buzzwords like machine learning, AI are today. And while looking for something to do in multimedia and internet, uh, I ended up at the multimedia, multilingual tools and internet technologies division, which was actually the GIST division at CDAC. And there I got introduced into language computing, right? So neither there was much of multimedia nor multilingual, internet, but a lot of multilingual tools or language technologies. And I had absolutely no idea that, I would end up uh, getting so deep into it. But the fact that the amount of learning that I got there, it opened my eyes into what really goes into defining something to be that never existed before, and then defining it so that many people can actually find it easy to use. And not just that, because I was also seeing how the proliferation and the usage was happening. uh, it became extremely fascinating and I would say engaging as well, to try doing it better for our users. Although in the 1990s the penetration of computer itself was very low, not many households in those days may have had computers to use. uh, but nevertheless, the print industry and many other industries, including the government, they were using Indian languages on computers. A lot of departmental work and communication, as well as publishing, was happening using computers, which meant that a lot of authoring happened on computers. So the things that I had to work on was to make publishing awesome, which also meant building great language tools for authors who can do great text input and text alignment, or what we should ideally say typesetting, but we are not able to do a lot of those today. The publishing industry does have a bunch of difficulties as we stand today. So, but the fact is that I got introduced to those, and therefore solving for the input, solving for authoring are the things that almost 25 years ago uh, did appear as the most important problems to solve for language usage. And I believe that those even today have remained to a large extent as challenges. Now, so we will go into my presentation now. But before I go in there, I just thought that I should start with a little story. Uh, you know, a short story that my mother had told me once. There was a hermit, I would say a sage. Uh, Before that, I have a habit of switching languages pretty often, and I can speak three languages: Odia, English, and Hindi. Uh, can I know if there are people who do not understand Hindi? Can you please raise hands? Others who do understand Hindi, don't please, if you have raised hands, pull it down. Okay, so there are two hands raised who do not understand Hindi. So in case you would not understand something that I have said inadvertently in Hindi, that you wouldn't understand, please raise your hand again. I'll try to explain that in English again. Okay, so this hermit, he used to carry out a particular yajna. That yajna used to be a very intense and big yajna that was quite specific to him, and he only used to be, yeah, knowledgeable enough to do carry that out. So he was doing it. That was probably once every 2 years, and so on. And whenever he will have that yajna, the hermit also had a cat among the different pets that he had. The cat had a habit of coming onto the lap of his master. So he would get the cat tied up somewhere so that he doesn't come and disturb during the yajna. Once the hermit, he denounced his body, then the hermitage was then taken over by his son. For some time there was no this yajna was not happening because he had lost his father, so he had to denounce certain yajnas for some time, and then when he wanted to resume, you know there was no cat anymore. But he did recall that uh, there used to be a cat that has to be tied up first before the yajna can start. So let's go get a cat. And he would arrange for a cat first, tie it up, and then start the yajna. But getting a cat or catching a cat is not a very easy thing. You can catch a kitten, but catching a cat is a little difficult. So year after year for the yajna, there used to be a lot more, research to, innovate how we can catch a cat rather quickly in short notice, and how we can tie it, more effectively, and so on. So that the research for the yajna started moving in a direction of catching and tying a cat. So now what I'm trying to aim at is that many times what happens is that when we lose track of the why, then we can get carried away into areas of work and research that are really unconnected. It becomes very important for us that we try and understand what is being done and why. So with that, I think we can start the presentation today. I really hope you guys, since while I would be in my presentation mode, I do not know whether I can see your raised hands for any quick questions. And if that is not happening, then please keep your questions, and we should go to each of your questions during the Q&A session. Okay. Uh, Okay, so I hope the presentation is visible now. We will go very briefly into uh, the the history. Now let's get into the background of text enablement. Uh, there are three factors to language usage on the computing medium. The first is that we must be able to create an encoding for the language. Why would an encoding be necessary? An encoding becomes necessary so that between one computer and another, between one software and another, they are able to understand the same things the same way, right? So therefore, we encode. For example, for English, we have the character encoding called ASCII, right? And today we have the character encoding Unicode that we are using for almost all the scripts in the world. And then we go to display, that is, we create the shapes of characters, and we also create the software that would render the characters on screen. So that is called display. And then we create input, right? So if you can now show text, then you have to be able to input the text onto the system. Now, this is a pretty intense activity. Input is not just designing a keyboard, because input actually encompasses the ability to edit, right? So every time that we create content, the maximum amount of effort goes in making sure that it is visible, or it is shown in the way that the author has wanted it to be seen. So a large amount of dependency actually goes into what is being seen, right? So based on that, many times we ignore these, and then we actually do not get to deal with the right kind of data that governs our computing algorithms. And now look at this one. This is the ASCII characters shown in the text mode in VGA screen. So the very early, when computer was used for communication, at that time, it became important to be able to show characters on a screen. So a screen was therefore introduced with something called as the text mode. And that was carried out by introducing a separate hardware called the graphics adapter, right? CGA, EGA, VGA. I'm sure there are some people who may have known about these or used some of these, but the fact is that these graphics adapters would be able to control the screen where all the display happens, and be able to switch between a graphics mode where you are actually dealing with any pixel as an XY coordinate, versus deal with it as a text mode in which the whole screen has actually been divided into character rows and columns. So when I said character rows and columns, it practically means that we are defining a character within a fixed array. So therefore, these graphics adapters used to have characters based on a fixed width and a fixed height, right? Now, I'm sure sometimes it might just appear that how is that connected to what we are likely to learn about Indian language computings, if at all we are talking about English. We'll come to that very quickly, and this background will become very important for us. Now we are going back into, having seen this, which was done for English, a graphics adapter that has been created to be able to divide or make your screen suitable for text display, So then adapting that for Indian languages, I'm just very quickly showing you a little history of the first encoding standard that was created for Indian languages. It says that the effort started from 1970. And then it went on evolving, and we created. So the background therefore becomes that majority of the development were happening for Indian languages during a time when the IBM PC or the graphics adapters and the Unix terminals and the graphics adapters for those terminals were the mode of use for hardware. Now let's look at what really happened in the days. I wouldn't really go much deeper into this. I can tell this story in much more detail, for people interested. Whenever, feel free to get in touch in case you want to. But this is a learning session, so we will skip some details which are unrelated to the learning part. So the efforts began in IIT Kanpur in 1970, where Dr. R.M.K. Sinha, who himself was a student at that point in time, initially thought of using Devanagari or working on a Devanagari OCR in those days. However, if you have to use Devanagari on a computer, you have to be able to represent characters of Devanagari on a computer. And to be able to represent them, you need to at least encode them. And that became the first step to work towards, what should be a Devanagari computer where such representations can happen. Now, in that, so that the idea was there on his mind, and then when he could, he gathered some of his students, and with his students, he started working on a Devanagari computer. And in 1983, the first integrated Devanagari computer was released at IIT Kanpur. The same was actually publicly demonstrated in Hindi Sammelan in 1986. Based on the encodings and the definitions that were created to develop the Devanagari computer and its technology, the encoding was standardized, and Bureau of Indian Standards released the ISKI as the first encoding standard in 1988. And we also had, our first keyboard standards that were also defined and eventually released as a standard in 1991. However, Inscript was the keyboard that was defined on the 101 key keyboard in the days. So all of these standards and computer were actually based on hardware, because like I mentioned, that there was a graphics adapter which practically divided the screen into a text mode, right? And only in that text mode could you really use text. So there was a heavy dependency on the hardware of that. So the whole pieces of algorithms and logic to be able to support Indian languages were therefore created into a chip. So the ASIC, called the Application Specific IC, called GIST 9000, and then 9001, and then 9002. They were basically the core hardware that powered the GIST card and GIST terminals. GIST cards were the cards that were used within those PCs, which could now show Indian languages, and GIST terminals were the ones that were able to uh, use Indian languages in terminals. Okay. Uh, and then what happened is that uh, here is a little, snapshot of the very first Indian language encoding standard called the ISSCII, which was created in 1982. And this was the standard that eventually became the basis for the ISCI standard. So this ISCII 7-bit encoding was revised in 1983, and this was the final standard which was used in the integrated Devanagari computer. I will like those who are able to look at the screen see that the column which marks 6 on the right hand side uh, actually is listing a bunch of matras, and you can see that the matras u, chota u, bada u, and so on. Those matras are showing a little square out there. That particular square ended up having a very big importance and significance subsequently. So that same ISSCII encoding eventually led to the ISCI ISCII, Indian Script Code for Information Interchange, that became the final encoding in 1988 and was then revised in 1991. And this was the encoding for the Indian scripts. Now here I'm not really mentioning Devanagari, I'm saying Indian script, because this encoding was created to be the superset for all the major 10 Indian scripts. Let's look at those 10. So it was listed like this: Devanagari, Punjabi, Gujarati, Odia, Bangla, Assamese, Telugu, Kannada, Malayalam, and Tamil. So for all of them, a superset, which is represented in Roman, and then also on to the extreme left, it is represented in a Devanagari look-alike. It is just represented. But all the 10 scripts were encoded in a superscript like this. That was the first encoding. Now let's look at a very interesting challenge. After the encoding and all the software that was created to be able to display and input Indian language text on the computers, there was a challenge, which was the printer challenge. Unless you are able to print, you really cannot make a physical usage of a computer for your languages. So therefore, now the problem also increased multifold, because you had a graphics adapter that you could replace, but the printers were also designed to be able to print English, which meant that the line height was 9 pixels. And therefore, the printer in the very early days were designed with 9 pins. With a 9-pin printer, you will be able to, as you can see in this particular image, the printer hammer prints one vertical line at a time, right? So therefore, it will be able to type print a line whose height is only 9 pixels. Within those 9 pixels of fixed size or height, English characters were okay to be defined, but all the software that was created to show Indian languages could not really design Indian language characters in such a short height. So the 9-pin printer became a very big challenge, and this had to be solved. Now that required a complete revamp of the the firmware that controlled the printers as well, and the fonts designed to be able to print. Now let's continue. Display. Display of Indian language characters till now has been the single most critical factor. Now, today, when we are looking at the use of English, you know, uh, the first thing that we do is to be able to read. And when we are reading, be it a newspaper or a book or something on your computer or on your tablet or phone, the thing that appeals to us is how good the text really looks. Many times our attention doesn't go there, and that is what is the beauty of the text design, right? If your attention doesn't really go into how readability it is and you are able to read it flawlessly, that is a good design of font. And many times, you know, publishers themselves are extremely keen about the kind of font design that they are using for their print. So for many publishers, if you open their book, you will be able to say that it comes from this publishing house. So that becomes their identity. And it happens with newspapers, it happens with books, and it always happened with, you know, the Indian language local publishing industry as well. So the display becomes very, very critical in adoption and usage. Now, when it has to be defined for computers, then uh, the factors that are super important to begin with is legibility or readability. It has to be so readable that it doesn't come in the way into analyzing whether it is readable. And the beauty of the fonts, that is, a font doesn't have to necessarily look stylish. It has to look it has to look serious. If it is a serious content, it has to look comic. If it is a comic content, and so on. So it has to carry the beauty to be able to make a reader feel serious about reading it. And then the sizes, because within a piece of text, you do have, you know, require sometimes a character written bigger or a piece of text written in fine print, right? So sizes become important, then attributes. Uh, we have got used to a lot of attributes like underline, italics, bold, sometimes strike through, and so on. But not all attributes are suitable for Indian languages. So, and many times we do not know, and we tend to force these attributes to Indian languages, and text becomes unreadable. Then the next other problem is composition. When Indian languages were to be introduced into computers, the bigger problem was that, you know, the ambiguity that it introduced just because it was a non-linear set of scripts. So in English, once you have all the characters and the character shapes defined, your there is nothing additional that is to be done to render characters on screen. Whereas when you are writing Indian languages, we all know that characters join, and sometimes they join either on top or onto the left or to the bottom or to the right, and so on, right? So that creates, you know, uh, because your data in the logical sequence is going to be different from the data that you see in the visual sequence, and therefore that leads to ambiguity. For example, if the E matra in Devanagari is to go to the left, but the logical sequence is ka plus E matra, right? And that is exactly how we learn in school also, ka mein E matra. Whereas in writing, the E is written first, or at least visually it appears first, right? And then because of these ambiguities, would it require to be standardized as well? That became a very important and key question. Let's stay with that question, and we will come back to it a little later. So now, when ISKI was defined, the most important aspect of ISKI was that it was defined and designed to be able to work alongside English. So we wanted that computer. Uh, uh, so in India, we cannot be using our local languages alone without using any of English. So English is a definite need. So what ends up happening is that we wanted, therefore, the whole technology to be usable alongside English. We wanted it to be an extension of ASCII, because English was already defined within ASCII. And so, for those who may not have the understanding because Unicode is popular today, what ASCII is. So ASCII is a definition of a character in a single byte encoding. Single byte means in 8 bits. Actually, ASCII is defined in only 7 bits. And in 7 bits, the total number of spaces that can, or characters that can be defined, is 2 raised to the power 7, which is 128. And ISCII, or the Indian scripts, were therefore defined in the upper ASCII, that is called the last, with the 8th bit. With the 8th bit, we got 256 characters, out of which 128 are taken by English ASCII, the other 128 for Indian languages, which meant that the number of spaces available for ISCII definition was very limited. And that being limited, it had a lot of pressure on how to define the encoding very efficiently. And at the same time, there was the other limitation that the whole display is supposed to be managed within just one, graphics adapter that controls all software. That means you can't have font choices. You can't have display choices. So therefore, within the encoding, there were a few things that were introduced. The soft halant actually meant an alternate display of a conjunct. So we will see some of those examples in subsequent presentations, but I am just quickly introducing some of these to you. Then there is explicit halant. That means if you are interested to write a word like a hridrog, which means heart disease, you don't want to put a rakar to the hridrog. It's not like that. Hrid and rog are two different words, with the hrid having a halant, which should appear explicitly. So the design of encoding itself meant that the halant would end up joining the two consonants that are to its each side. So to avoid that, an explicit halant method was introduced. A triple halant method was also introduced for an alternate display. An invisible character was introduced. This invisible character was given the status of a consonant, so that it doesn't. It would rather help in keeping two consonants from joining each other, and it also helped a lot with editing features. We will come to that a little later. And then unambiguous conjunct encoding. Means we know there are 3 conjuncts that we read alongside our alphabets, that is ksha, tra, and gya. But these are conjuncts formed out of independent consonants. For example, if you are looking at ksha, it is ka plus the shatkunsha, or tra, it is ta plus ra, and so on. So if these are also encoded as independent characters, then these words will get written in 2 different encodings, whereas they will look the same, right? So therefore, an encoding's objective, or a standard's objective, is that it should be able to represent with absolute unambiguous ways. So these were all the things that were done, and these tell us that while display forms were super important, and since it could not be handled with alternate fonts or display methods, they were included as part of the encoding in the early days. And therefore, let us say when we evolve, we are not supposed to take these along unless we understand why they were included at that point in time, right? While at the same time, also because there was very little space available for the encoding, the extension and the extension character and the attribute characters, these were also introduced. For example, the attribute character will be able to give an Indian language attribute to the English numerals, so that you can look at the English numerals also in the script of your choice, right? So those are the sort of things that were done within the encoding. Then composition, once again, that remained a display problem, which I have already spoken about. These are the real images from the ski standard, where the soft halant, the invisible consonant, and the nukta and the explicit halant are all the display forms that have been pretty elaborately explained here, with examples about why it is used and under what circumstances. The fact, therefore, is becomes evident that when we are computing, we are supposed to normalize or ignore within software. These have a purpose, right? If they do not apply into a modern encoding, then we ignore them, or if they do apply, then we normalize them. So understanding these becomes very important when we are trying to process data for our advanced machine learning or AI usage. So let's get back to the history where we were. So after those definitions, and based on that, the software that had been created for the non-graphics kind of environments. Uh, in the 90s, there were graphics environments that got introduced, and that also therefore meant that we were able to use scalable fonts. However, there was a huge problem within the non-graphics operating systems. It did not support multitasking. That means you were not running a service that could actually give a font rendering service to many different applications. Or let's say if you were implementing a word processing or a spell check, that it will become available to 10 different applications separately. That was not possible. One application had to basically implement all its services within itself. Whereas when the operating systems were now designed with graphics and were multitasking, they were running on much better hardware. Scalable fonts were introduced, and the font rendering aspect, which was until that time was completely driven only by the hardware, the graphics adapter, was now carried out by the software. That means it now became a service within the operating system architecture. Now that also introduced certain limitations. That is that the rendering engine, if the rendering engine becomes a service within the operating system, then you cannot enhance the rendering engine anymore, because you can't change a service within the operating system which the operating system would not be compatible with, or it would not understand, and so on. For example, on Windows, you really can't replace services, right? And Windows in those days was the most popular operating system, and the next was Apple, but Apple did not have any Indian language. Of course, even Windows didn't have. So the fact is that that became a limitation. With that limitation, when the same software which were being used in the non-graphics operating systems were to now be ported onto graphics operating systems, and more advanced software were to be created, then this display problem had to be solved. So therefore, these are the two things that people did. They started creating fonts which were laid over ASCII layouts. It was not by choice, it was by force, right? And then there was also a requirement that English language should also be used alongside Indian languages. So these two critical requirements, uh, a font started looking something like this. So you can see that a font layout which was supposed to be created for ASCII, the shape of A is replaced by something of them. This I've taken the DVTT. It's a free font from CDAC. So so basically, instead of the English character shapes, the Devanagari character shapes were used, and because of that, if you have actually written some English text, it might start looking like gibberish Devanagari text if this font was selected. Whereas if an appropriate composition was created that could map the proper ASCII characters sets into the glyph shapes of this font, then it will start looking like legible text. However, these kind of solutions were there. But the great advantage of this kind of solution was the disadvantage was that different companies started coming up with their own glyph set designs based on this different layouts of their own. That created a lot of incompatible fonts. Whereas if all of those had followed a single layout, then it solved the compatibility issue altogether. To be able to do that, a new standard was created called the ISPOC, Indian Script Font Code, which meant that the layout of these glyphs for all the languages would be released as a standard. And all the designers who are designing fonts can now just pick this layout and create great designs. That worked as magic. A lot of fonts for different scripts in different states, towns, cities. Many designers who were great at designing, they started creating fonts, and the publishing industry, benefited from that big time. And publishers had a lot of choices. Alongside that, there was, however, this very interesting requirement. The default English is not really usable alongside Indian languages for a simple reason that you can look at on your screen, that within the same character height, if you write Indian language characters with the base height remaining the same, then it will still require additional space on top and bottom for the matras or anything else, matras, vaktus, and so on. So that meant that if the Indian language characters are designed within the same height of English, they will look smaller. If English characters are designed to only the base height of Indian language characters, then the English characters will look smaller. So therefore, matching English and Indian language fonts had to be created. Now, let's also look at how the input was handled. Now, to be able to handle input, there was, there were quite a few initial challenges. That the major input tool until that time was the typewriter. And a typewriter has got no logic. It does not have a processor of its own that can actually do any arithmetic or logic, unlike a computer. A computer has got an arithmetic and logic unit. So even if you give it a logical sequence of characters, it may be able to show you a different visual sequence. Whereas in a typewriter, you have to look at the visual sequence to be able to type. That is a little counter to the way that we have learned how to write. Because when we learned how to write, we learn the alphabet first, and then we start learning the matras which join the consonants. So matras join the consonants. We never write a matra before writing a consonant. So when you look at typing, where that becomes a necessity. So designing the input based on this was a very big challenge. But considering that it would be much more effective for children to learn the same logical way, a logical keyboard was designed. But would it still have to be on the same hardware? Let us understand that the hardware keyboard that we have today, the QWERTY keyboard on which we type English, has been on the English typewriter and has also been the first keyboard designed for computers. The same layout has continued because it is a hardware after all. For every key, a particular code has been assigned, and when you press that particular key, it generates that code, and that is how it is interpreted. So the whole software that interprets these keyboards only understands these many keys, and we haven't gone back to change this for any language. A particular design, which is physical and was designed for the English language, has basically been used to adapt to other languages. So there obviously therefore is a bit of a disadvantage that it was not ground up designed for our languages. Our languages are to be adapted into this design. So considering that the ease and speed needed to be, very deeply thought, something that people can learn and they can retain, and eventually with time be able to earn enough speed in typing. And the first InScript keyboard was created. I believe that InScript is still a standard that is available on majority of the operating systems as well as mobile phones and tablets that support Indian language typing. Okay, now having designed the font and the input methods and all of that, the most important thing that was is to be designed was the editing algorithms. That how should the whole thing behave when you press a backspace, when you press a delete, when you have to move your cursor up, down, left, or right. Because in English, you have just one character at, facing to the left or to the right of your cursor, or to the top or to your bottom. But in Indian languages, if it is a conjunct, then it is it's a bunch of characters. Then how do you basically move your cursor? These are problems which many people have, no more been paying attention to, and these are the reasons why Indian language authoring and editing remains a very big pain. Very recently there was a report that was released by Google in a blog, I think, where they said that Indian language typing is 3 times more difficult than English typing, as mentioned by users. So the fact is that we have not tried to solve certain basics, or certain basics which were solved earlier, have more or less been ignored. So today, when we are doing something with English, do we not really need to select, cut, copy, paste, so that we are able to quote certain things somewhere and so on? We are. Whereas when it comes to Indian languages, we really do not have a uniform way of, handling cursor movement, select, cut, copy, paste, and so on. So these were all designed. And how were they designed? There was a very interesting aspect that was defined within the ISKI encoding. So it defined what is the syntax of scripts. That means it basically broke down our character set into vowels, consonants, matras, and diacritics. And then uh, it also had, halant, nukta, etc. Then it defined what is a syntax. So it's basically common sense that you and I know that, only matras can join consonants. Vowels do not join a consonant as such unless it becomes a matra, right? So two consonants can join, right? They form a conjunct and so on. So basically it started writing down that as the script grammar, without which, unlike English, any letter cannot be placed around any other letter and still be valid, right? So this was a phenomenal definition that was important to be in a computing standard that can implement the character encoding for those language usage. Uh, Once this was defined, it meant that certain characters, if they exist, they can exist only with certain other characters. If they don't, unlike English, they will be in a void. That means if you write a matra, only a matra, or only an anuswar, or only a visarg that doesn't join anyone, then it can't exist. You can't pronounce that. It doesn't have an existence in any of our scripts. So this makes it legal or illegal. And to be able to show what is illegal, or there is a void into which it should have joined, something very interesting that was introduced called as the dotted circle. So here is an image from the ISKI document, and I said that let us spark that little squares that we had seen earlier in the ISS CII 1982 document, 83 document, where small squares were introduced, and eventually, that evolved into becoming dotted circles that had to be implemented into the Indian language implementations. So you will be able to instantly identify that a character sequence is illegal, and therefore it is either an inadvertent typing error that can easily be corrected by the software or by human verifications whenever you are looking at data, or such data have to be rejected if you are actually trying to auto process that for your AI or ML usage, right? So these are ambiguous. Now, that is the degree of definition that went into that. Uh, but let's look at what happened next. We do not use ISKI, we use Unicode now. And Unicode encoded Indian scripts for the first time in 1991. 1991, Unicode's first version came in, and when they were coming up with the very first version, they wanted to adopt as many scripts as possible into their definition, and they found that India was already developing commercial software using their own encoding called ISKI, and they adopted the ISKI, which had been defined in 1988, not the 1991 revision, but the 1988. So nevertheless, it was still quite good. And when they picked it up, they actually picked up this ISKI table, which is the superset for all scripts. And when they picked up this table, they thought that all the characters mentioned here are Devanagari characters. If you all recall that when we looked at the language lists, Devanagari was not the superscript. Devanagari had its own position. This superscript actually had a lot of pseudo characters which were to encode characters from Tamil, Malayalam, Odia, Assamese, Bengali, and so on, right? So they did not have a Devanagari representation, so they had been created out here. But Unicode ended up using the whole set from this as the Devanagari code set right at the start. So when that happened, what ended up happening is that we had some characters introduced into Devanagari which were not used by any of the Devanagari based languages. And those characters have eventually, over time, been used confusingly in Devanagari texts. So that introduces spelling errors. And we will learn a lot more about that subsequently. Let's look at what else happened. Assamese script was merged with Bangla. Now, that also ended up creating a lot of text incompatibility between the two encodings, because Assamese is not a subset of Bangla, nor is Bangla a subset of Assamese. So what ended up happening is that there were actually characters which were disjoint from these two sets. So it could not fit in properly. If we look at, let's say, uh, okay, I'll come back to that later. And then they also ended up introducing the zero width joiner and zero width non-joiner. So I have mentioned earlier about why ISKI introduced an invisible character and why it introduced a soft halant and so on. Those were display variances which had been documented separately only for academic usage. And they were not a part of computing. They were for academic usage in those days because there were no font options that were available. The systems that were dependent entirely on graphics adapters and could use only one font for the whole system, they did not have a font choice and therefore had no choice for display variances. And therefore, it was introduced only for that and could be easily ignored into a futuristic encoding. Whereas the future encoding Unicode ended up creating zero width joiner and zero width non-joiner by taking cue from those invisible character and soft halant, etc. What was worse is that basically the Unicode encoding has ignored everything else from the encoding, earlier encoding. That is, we no more had a script grammar. There was no logic to the character sequences or the classifications or any of that, which therefore ended up you know, getting a lot of, legitimate software that were complying to Unicode, but apparently were very ambiguous in usage for Indian languages. Okay, so apart from the Unicode, what the display, we have looked at, how the display was being handled among fonts. So let us look at what happened with display. Uh, the the ASCII based layouts, which were obviously, different people were creating different layouts. So that was creating some amount of incompatibilities, were now replaced by an open type layout. OpenType was not really a layout. It was a totally new font format, which also required a completely new font rendering engine. And since it came within the operating system in Windows, therefore, it was just one company which was creating and making and distributing. That was Microsoft. And since only one company was giving that, there was no incompatibility, because every other software that would be working on Windows will now be able to use the open type. So none of the Indian different software providers uh, will now fight for incompatibility. They will basically cease to exist. They will wind their shops, and so Windows would work for open type. The uh, the what we have seen is that although Windows introduced OpenType in the year 2000, it was already 10 plus years since the introduction of Unicode. That means, although Unicode was created in 1991 for Devanagari and so on, the first Devanagari support came in Windows 10 years later. Uh, until now, that is till 2020, we have only one in most cases, or at most two fonts for most of the Indian scripts, right? Uh, in majority of the operating systems today. The so if I would try to compare that, if technology were to be solving this really well, then the designers who were creating variety of fonts given a fixed layout, there were, so let's say if any one language would have 10 varieties of fonts, then 10 languages would have at least 100 fonts from the same foundry. So that is the kind of options that people had. People actually had hundreds of fonts for many Indian scripts. Compare that with today, we have one or at most two fonts in majority of the operating systems for any Indian language. Now, with that, mm, even with this, most of these fonts are not working well with the different word processing software or WYSIWYG viewers like PDF or graphics software and so on. So that practically has thrown us back many years in advancing or using Indian languages more rapidly. What is worse is that, in spite of that dotted circle being there, because there is no script grammar that is introduced either into Unicode or into OpenType, you have the ability to type many words in ambiguous ways. So you will look at many more of those in subsequent presentations. So it introduces a lot of ambiguity in typing. Now let us look at, what are the Indic specific things that we need to do, and how we can really, accelerate, what we have been, what we have been doing. I mean, the problems that we have basically been seeing introduced, how we can get across those. Uh, the Indic specific properties, we have already seen that, those are non-linear. It needs a fresh architecture for, modular and linked visual and logical data. That means, uh, what does this really mean? Is that because the open type font rendering engine, for example, which supports the display of any language, if I am a Santhali user, or maybe I am maybe a Kosali user. So which is a tribal language, or maybe some other script in India. And I know my script very well. I can create a software, I can create a font, but if the rendering engine doesn't have my language support, then I would not be able to make it run on Windows or on any other operating system, on my Android phones or on my iOS phones and so on. So that would mean that I will be limited by what the ability of my operating system has. The same way, if I am trying to author something and I have created or developed a beautiful spell checker and a grammar checker using a lot of data and knowledge, I would not be able to enable my email application on the phone with my language. So these are the problems that are there because the language usage is facilitated only through the operating system and is not, it is rigidly closed. So if, so we need, of course, a fresh architecture that is modular and also links the visual and the logical data. So lack of this architecture has been restricting. Then the script syntax. It's actually the single most important tool that I mentioned, that when we are using the script syntax that we saw, then we are able to process text very, very rapidly, very, very accurately as well. Then the logical arrangement. This itself is a huge arithmetic advantage that we have. Uh, just to give you a compare, when we are looking at English alphabet, uh, do we really see any relationship between the adjacent characters? Does A have any link with B? Does B have any connection with C? Or and so on? None. But when you look at Indian language characters, we have all the vowels coming first. Then we have got 5 vargas of consonant. They are sequentially arranged, and with a sequence that is also uniform across all the vargas, each of them ending with a nasal. And then we have got out of varga consonants, and so on. So if you were to design a software, even for a new language, for the large part, even without knowing the language, by simple arithmetics, you will be able to create a lot of usable tools, right? Which is something that is a huge advantage for Indian languages. Then there are certain vulnerabilities that I would like to caution, that the use of Anuswar, which I'm not very sure if most of you, if you are developers, if you do use Anuswar as a normalizer, uh, that is because like we can write certain words in English in multiple forms, we can also write certain words in Indian languages in multiple forms. Like Hindi is written with the half na or with a bindi, the Anuswar. So Anuswar is practically a nasal replacement for all Vargiya consonants, right? And this uh, a, uh, is a very big advantage. Uh, Sometimes people write that as a normalization rule among many other normalization activities, but you really do not have to enumerate. You actually have to just use this as a rule, and that works all across. Similarly, script specific introductions into Unicode, they are a huge deterrent. For example, the introduction of multiple vowels into Devanagari for for English words, English pronunciations, and also specific introductions of characters into Malayalam and many other languages as well. So those requires certain actual deeper study to be able to enumerate and screen those. The introduction of zero-bit joiner and non-joiner, a massive deterrent. Many times it goes unnoticed, and most of the software developers do not know or would have missed out writing a tool to screen those and or handle them. So for most of these, we will actually in the subsequent sessions also release a lot of open tools that should help the developers use your current processes much better. Here are certain tips. Like I mentioned, the alphabet arrangement itself is a mathematical takeaway, and therefore it provides a huge amount of advantages. However, that has got um, one little trick that I must mention, that when you are looking at the edit distance algorithms in English versus Indian languages, then majority of the algorithms that are like byte pair encoding, etc., they would normalize repetitions like doubling of characters and so on. Whereas in Indian languages, doubling of characters often will not appear like that. They will come with a halant in between and so on, and because of that it would not appear like doubling, and so it will such algorithms will fail. So you have to keep that in mind and make necessary modifications into your algorithms. Then encoding choice, this is a very big one. I am not sure. There are two documents that I would recommend anybody who is working on Indian language computing. The first one is written by Dr. R.M.K. Sinha himself, the journey of Indian scripts. I don't remember the full title. I will share that subsequently. That document and the ISKI document itself. It's very important because uh, there are a lot of mathematics that has gone behind the choice of encoding that has been released. The current or the first ISKI encoding scheme that was released, it was a choice based on the amount of storage and mathematical or operational efficiencies that you are likely to get. Along with that, there are a whole lot of other benefits that you get from this scheme of encoding in terms of the ambiguity of usage. Whereas there are other advantages that you get when you choose a different scheme of encoding. Now, why should we even bother about a scheme of encoding when we are talking about languages, when we already have one particular encoding standard called Unicode? Now, as computing or developers, it is important for us to be able to develop efficient algorithms. Even simple maths are encoded differently when we are developing underlying technologies. So encoding choice becomes very important. These documents have given multiple different encoding choices that you must look at. And then finally, normalization. Normalization for Indian languages is significantly different from English, and uh, there is no one handy tool that you may find in a public domain. We are trying to hand out some, and I think that should benefit many of you. So here is a little wish list that I have. We have known that most of the adoption of our languages has been gated at technology. So technology, instead of being an enabler, it has practically been, I would say, uh, a hindrance. I would say a friction in adoption. Like many times, I have seen people saying that if users are using English script to write their mother tongue in messages in WhatsApp and so on, then we should look at standardizing the English script. But the fact is that the very same people often would write a letter in their own own script and in their own language. So if in writing you are taking that choice, why should technology be a limitation? So these limitations have actually been solved in many places. It is just that they are gated at the technical architecture that we have today. So we should be working at at that. Then focus on non-transactional use cases. So what I have seen is that in my long experience, I have seen uh, that the greatest use of language has been when we are able to enable people to read and write and author. They are able to create. So we see that a large amount of focus today has gone into an online e-commerce or those kind of things being spoken about as the most important ones. The fact is that ev- each one of you, including myself, when we have a curiosity in our mind, the first thing that we do is we search on the internet and read. And we do that probably many, many times a day. We don't really go doing online shopping every day so many times, right? So the non-transactional use cases are the only ones that will empower people, because that is where knowledge is. And then digital literacy. This I have been speaking a lot, that we have not really been empowering people by making them aware how typing can happen. We know today, and probably earlier as well, that our languages have been force fitted into an input hardware that was not designed for our languages. It was designed for English. However, although we accept it, but how our writing system translates into the digital typing system is something that is not going to come to us very naturally. We need to learn that, and therefore we need to teach that in schools as well. So focusing on that makes a lot of barriers go away. So that is all that I have. I think I have spoken a lot of things. Maybe some of those were interesting, but some others may have been boring. But I believe it must have uh, got some of you thinking. If there are questions, I can take for a while. Okay, what is the use of it? What is the use of what? I could not really understand. Uh, okay, maybe the question is that what is the use of trying to know whatever that we have learned now, right? Now, uh, I see. So I would not be able to give all the details right now. This is a background to how Indian languages have been designed for computers and implemented, and how that has flowed so far. Now, why is that background important? It is like I explained about the cat. Today, we may have forgotten about it. There are about 10 sessions that we are likely to have, out of which about 6 sessions will be around machine learning for different tools and use cases. And when we are looking at all of those, many of these information are going to be prerequisite or handy when we are learning that. So this is like understanding the background of why we tie the cat. Okay, so I have two questions. Usage of NLP. Top three things that we can use. Uh, Examples from Siri or Alexa. See, Siri and Alexa are assistants, and if you were to look at top three, uh, you can only understand the top three use cases when there are many use cases that have already been implemented. For example, there are a bunch of use cases implemented, and within that also, if not in India, the data from the US are from large number of users across different use cases. Mostly it is about entertainment, map usage, and information. So these are the three top usages for digital assistants. Are there technically inbuilt tools from you for student learning? Uh, it is the question is not very clear. Pratigya. So, the question is not very clear. Uh, if you are talking about an education tool, I don't have, we don't have any education tools. Uh, Students can learn and experiment. So, but if it is about language computing and learning about how you can develop different tools or process languages for many of your, machine learning and AI, then those definitely are there. And in the subsequent sessions, you will get access to a lot of those. Since keyboard is a challenge, why not push towards voice or text? Voice to text. Oh, okay. This is a great question. Now, let us say if we have cars that can run on roads, do we stop walking? If there is a keyboard, we will be able to type whatever that you really need to type. If it is a voice, we are depending on a technology that will interpret for us. We may not always be able to get what we want to write, and therefore it will be a limiting one. It will be easy, but it will be a limiting one. So for example, even in English, with all the advancements in voice to text, we have not given up on our keyboards. We still use it because it is a very essential tool, and it is silent and it is private. I feel the only way to preserve Indian languages is to empower it with digital technology. Sadly, none of our languages wars between Indian languages will help in it. What do you think? Yeah, of course, language wars will not help. Okay, I think I am out of time, uh, and we will go to the next session. Pranjal will be speaking about more tools, and they are going to be very important tools in computing. We will come back to speak again. Over to you, Pranjal.
Thanks, Vivek, and thanks for that interesting session. So it was pretty engrossing. To am I audible?
Yeah.
Okay. So yeah, I mean, you can probably stop your share, Vivek. Yeah. Okay. Thank you. So yeah, thanks for that session. It was pretty engrossing, and I hope everyone could get some insights into how our languages have moved over the course of last 50 years, and what are the more important basics of our languages. So to everyone, welcome and good afternoon. I'll be basically covering two sessions. So in those, I'll be covering the challenges of in Indian language computing right now, and what I'll be doing is that I'll be covering a part of that in today's session, and a subsequent part in the next session, where we will be talking about more about in editing input methods, keyboards, and all what we can do. And today's session I'll be just covering mostly around encoding and display and certain rules, which we already touched upon, but I will be taking you through certain examples which may make it more relatable to you in terms of it. So let me start by presenting my screen. So hi, I hope the screen is visible. Vivek, Krishna, any one of you could just give me a cue whether it's visible.
Yes, it's visible.
Okay, thank you. Yeah, hi. So I'll be covering challenges in Indian language computing, some of which I'll be covering in this session, and some of which I'll be covering in the subsequent session. So Vivek mentioned about the three strong pillars of Indian languages, right? So those three strong pillars happen to be the challenges as well. So encoding a definition of a finite character set for our languages. So when you talk about English, right? So if I ask anyone how many alphabets are there in English, answer would be instant 26, right? So but if I ask how many characters are there for Hindi, so I am very likely to get different answers from different people. This is because our languages although there had been a lot of efforts in encoding and to what Vivek mentioned around ISKI and all, our languages today have been polluted to some extent, where a lot of characters which are not in use for that particular language have come into being, and mostly it has been to try and accommodate sounds or words which are foreign to us. But have we even thought that whether English will tomorrow increase from 26 alphabets to 28 just to be able to say include something which is Russian? It will not, right? It will still try and use the same 26 alphabets and try and pronounce it or represent it rather in the best possible way. So second is accurate display. Vivek touched upon this as well. I'll be taking you through certain examples on this. So I'll be speaking about a bit of the inefficiencies of the existing display standards, some of which again Vivek has touched upon. So some of this might be a little bit of a repeat, but I'll be taking those through with certain examples. And also the availability of good quality fonts. So this happens to be a challenge for Indian languages, which is definitely not the case in English. You can get a lot of fonts for different styles. Even while writing this presentation, right? Even while creating this presentation, I had the choice of various fonts in English. But if I were to write this in Hindi, I would probably end up with just a couple of choices, or probably 3 choices, and which might be even less when I talk about other Indian languages. And lastly, standardized input methods. So InScript, Vivek mentioned, is the closest thing which we have to a standard. And this was a standard defined for 101 keyboards for your desktops and can be adapted to the laptops, right? But for the more popular mediums like phones, smartphones, feature phones, tablets, which are which are of mass usage. So there are no standards which are available, and there are a lot of keyboards which are available, but there is no standard which is available. So just think of a 12 key keyboard. So our 12 key phone, right? So there's feature phones, the Nokia phones, which we used to use probably about 10-12 years ago. And everyone knows, like on the key 2, so on the first press you will get an A, and the second press you will get a B, and the third press you will get a C. But do we know like where we will get a it in certain phones you will probably find it in the key 1, whereas in certain phones would have implemented in key 4. And this is where the non-availability of a standard comes into the picture. And secondly, no standard knowledge of typing, so which is being taught in schools. So if you look at the school curriculum today, so there is a knowledge which is imparted in the schools for typing in English language, right? People become at least typing proficient in computer, in English language, but the same is not there for Indian languages. So I'll be covering a little bit on encoding and display in today's presentation, and subsequently in the next week's presentation, I'll be covering more around input methods and editing. So on encoding standards, so as some of this might again be a little bit of a repeat. So ASCII was the encoding standard which was developed for English, and I'll not go much deeper into it. Just I'd like to highlight one point, just to develop a standard where it seems very trivial, right? You just need to put some some values to each of the characters, but a lot of thought went into even defining this and trying to put it. Or say lay out the characters basically, and a lot of thought around computing was being put, like how to make searching easier, sorting easier, any sort of operations which are likely to happen easier. And for that it was defined in a certain way. So if you just as an example, if you just look at the small case and the uppercase alphabets, right? So if you look at the positioning of the small case and the uppercase alphabet, so you could move from one case to another by just the change of a single bit. So that's the sort of level of optimization which went into trying to do a standard, and that's what the standard for ASCII was developed. And hence it got used as such in the following standards which were developed for Unicode. So continuing with encoding standards, so Vivek touched upon this. So ISKI was created in 1988, and then it was revised in 1991. So ISKI was created by Bureau of Indian Standards. So ISKI defined a finite character set in accordance to what is taught in schools for each language. So this is a very important piece. So what ISKI did was to actually define for each language in a way that it only encoded the characters which was common knowledge, basically, which was taught as we were to learn languages. ISKI was defined to coexist with ASCII. So at that time, computing was limited to 8 bits, basically a single byte. And since ASCII had taken up the characters which could be encoded with the first or with the 7 bits, so ISKI was left with the next set of 128 characters which was used, and it was and all the Indian languages were encoded in those upper ASCII range so that it could coexist with English. So as Vivek also went through a lot on the ISKI document, it was a comprehensive document which explained also the character behavior. It is not just assigning a value to the character, it explained how each character should behave, how the characters in Indian languages should join each other, and how they should form displayable units. So now coming to the Unicode standards, these are encoding standards created by the Unicode consortium. So Unicode actually encodes for all languages in the world, and it also obviously created encoding for major Indian languages, and every year certain new languages get added to the encoding. So as Vivek also mentioned, it ignored ISKI as a guiding document, and certain principles or certain learnings which were being incorporated in ISKI were not being taken up by Unicode, and it introduced a lot of archaic and junk characters, and it creates confusions and introduces certain errors. So what does it? Why is it that the introduction of a character or characters which are not native to the language is a hindrance, right? You would probably think like people might just be not using them; they are just present, but it's not that simple. The shapes and all are not very different from the ones which are your actual character, and you end up using certain characters, and what it does, it happens to pollute our it happens to pollute the data, or pollute the corpus which sort of gets created by using those characters. So if you look at this is what the Unicode at the extreme left is what the Unicode code page for Devanagari looks like. So it tries to encode all the possible Devanagari characters. This is not just for Hindi, this is for all Devanagari based languages, which will include Hindi, Marathi, Nepali, Konkani, and so on. And if you look at the middle one, this is the BIS code page which they have introduced in their IS 16333 document, which is for support of display on mobile devices. So here the grayed out characters are the ones which are not needed for Hindi, and the rest are needed for Hindi. Even if you look at this closely, there are characters which are not taught in school, or which we do not recognize as Hindi characters. So if you look at the extreme right, this is the Devanagari character set which should be present, basically. So I just wanted to show the difference of what is being accepted as a standard and what actually is being taught in school and what should be present. So why does this? Why is it so important, right? So here is some findings. So say for any NLP activity, you would want to work on some data source, right? So or any available corpus or anything. So here are some findings from a Wikidump. So we took the Wikidump for Hindi language and run character level analytics on it, and we found that certain characters which are not native to Hindi language had a lot of usage in Hindi language as well. So what it effectively does is that it actually pollutes the data. And why I am showing you this is that while using anything of that sort for your NLP activities or any other activities, you can just use this knowledge and try and filter out words or even sentences which may have such pollutants, so that you have a more cleaner data for your activities. So idea is to just show you that because the encoding has been polluted to an extent, so it's very likely that any corpus or anything that you are referring to might have something which you may need to be wary of and try and guard against while creating your own algorithms, or rather using that sort of data for your algorithms. So now let us look at an interesting search problem. So we'll just see the problem, and then I'll talk about why the problem is. So here is a page on Dainik Bhaskar. So and there is the word home, which is a transliterated form for home in English. And I did a search on home, and I got four matches. But if you look very closely on this page, there are two other places where home is also written, but the search did not match them. Now I again did a search and I got 2 matches, and the earlier search, which had 4 matches, is not showing up here. So I'll go back for your reference just so that you can just take a minute to watch. So you can see which all 4 got matched here and which 2 got matched here. But I am searching for the same word, right? It appears as if I am searching for the same word. So why is that we have this issue? So is it really that the same search resulted in 2 different say results, or say 2 different outputs basically? So let's look into it. Let's look a little deeper into it. So as we see, right, both the searches are for the same word, but it yields different results. But are they actually the same words? So in actually, means in reality, they are not the same words. They do look same. Visually, they are same, but at a character level, they are not same. So in the first case, the character combinations are ha, o matra, and ma. Whereas in the second case, the character combinations are a and a matra, on top of that a matra and a matra, and then ma. And even though it looks same, right, the composition is different in both the examples. And you could see that the results were also different. And what is interesting to note is that it was one article, right? So I'll go back to the article again. What is interesting to note here is that this is one article, and you within that article you had the same word written in 2 different ways. So somebody might have created article, somebody might have tried to create I mean, somebody might have written this article, but while even writing, they created the same word into different forms. And as we go along, we'll see why this happens and what can be done to prevent those. There are a couple of ways how we could prevent these sort of things, and we'll be talking about one of them today, and one in a subsequent in a subsequent session. So on this, so yeah, they both look same, but actually the composition is different, and that's why we got different search results. And in this case, actually the first representation or the first combination of characters is correct, and the second is a wrong way of representing it. So we'll also look at why both the combinations look similar as we go along. But first, let's look at certain techniques of how we could probably solve this. So how do we solve this? So we at Reverie generally look at solving such issues by doing something which is known as normalization. So we follow 2 basic steps at normalization. Firstly, we normalize all the matra and the vowels which are formed by combinations to the correct single representation. So you could have as in the examples, you could have a vowel being formed by a and a matra, and the o vowel, as in the example of home, being formed by a and a, and say o vowel being formed by combination of and I and A, or it could be a combination of and O matra. It could be a combination of I and A matra. So there could be various combinations which could come together and form, and there is a basic flaw or an issue because of which this happens. But how we as developers could prevent this or like overcome this while using any corpus and all is that we can introduce this sort of normalization. And as Vivek mentioned, we subsequently we will be releasing certain tools which would help you guys to use those tools and do this normalization. Secondly, you can also normalize the nukta characters, and you can normalize them to the character and the nukta. How this helps is that many times you may need to search for a word where you might miss the nukta. So in your search and all, if you have normalized in a form where the character is separated from the nukta, it's easier to develop algorithms to perform those sort of searches. So the second normalization that we do is basically normalization of the nasal words to a single form. So if you look at these examples, Hindi or Hindi, Nand and Pant. So in all these three examples, basically all three are correct, right? So means all the both the forms are correct in all the three examples. But for consistency, we always normalize it to a single form. You can let the statistics decide, or you could have like it normalized to just the nasal Helen form. So we will not be recommending or forcing anything on this, but it's what we will be recommending is like it's better to normalize to a single form so that you have more consistency in your data. And of course, if you are using it for any NLP sort of activities, so what it will do, it will make your data more compact. You will not unnecessarily have basically similar forms of the same and just being written in a different way just from a, because these are like just representation forms, right? These are not really where the word is changing. These are just representation forms. So now dealing with zero with joiner and non-joiner. So Vivek mentioned about zero with joiner and non-joiner getting introduced. So zero with joiner and non-joiner are mostly added while representing Indian language words. So and they are done mostly to create different visual representations. So we'll talk about zero with non-joiner subsequently in subsequent sessions. But on zero with joiner, just like to look at these three examples where as a as somebody who is publishing, right, I may want to create different fonts uh, so that I create a different visual form. And in all these three examples, the first are the left sides are the ones where it's the normal form without the introduction of a zero with joiner, whereas the right hand side, the zero with joiner has been introduced in between the conjunct. Basically, in the word Ashwin, between Shaw and Wo, the zero with joiner got introduced. And with between the two ters, the zero with joiner got introduced. And in Vyakti, between ka and ta, the zero with joiner got introduced. So these are mostly done to try and create more create different visual representation. For most NLP purposes, you can definitely ignore zero with joiner and create your data without having the zero with joiner. You could just normalize your data to ignore the zero with joiner completely. So moving on to a little bit on the history of display systems. So Vivek has touched upon this. So the early terminals and command line operating systems, so they did not support multitasking and they needed self-contained applications. So basically the applications themselves had display systems which were running inside the application, and they were mostly designed to use fixed size bitmap fonts. So bitmap fonts are fonts which have the exact pixel information in those fonts. Those are not your typical fonts which you find in your desktop laptops. So those are fixed size fonts, and if you need to use for any size, it has to be developed for that particular size. In today's real example. I didn't put it on the slide, but in today's example, if you look at, say, your BMTC buses boards, right? So the BMTC buses boards, those will have bitmap fonts where they display the information of the destination and all. So those will be carrying bitmap fonts. The feature phones, so the feature phones, not the smart feature phones or not the 4G feature phones, the 2G feature phones, basically. So those would all carry fixed size bitmap fonts. So yeah, from the early terminals, then we moved on to graphics operating systems, which introduced scalable fonts and the multitasking as well. So font rendering became an OS service, and at that time computing was limited to 8 bits, as I had mentioned earlier. So the fonts had to be also be defined within that 1 byte range. So it was limited to 256 characters, of which actually about 64 characters were control characters, which limited it to about 190 odd characters. So needed to design the Indian language fonts within 190 characters. So when designers went about designing their fonts, right, for Indian languages within this 1 byte range, each designer started creating fonts with different layouts. And what eventually happened was that fonts got created for a single application, could only be used in that application. Although it could be installed at a OS level, I mean, you could practically not use it for another application. I'll just touch upon one example next slide and just try and explain that bit more. And each application started having their own algorithms, uh, basically trying to map to the specific font which it was trying to support, or the specific font for which it was developed. So this created a problem of uniformity for the Indian fonts, which got created. A lot of Indian fonts got created, but and a lot of popular fonts are in use today as well, but they get used only in the systems which are compatible with those fonts. So this problem was solved by ISFOG. So the ISFOG was a standard which was created by CDEC. This did not become a published standard from Bureau of Indian Standards, but this was a widely used standard for font development. So if you look at this slide, so I'm trying to show you two different layouts from two very popular Hindi fonts. So the left side is the Akriti font, and the right side is the Krutidev font, which is pretty popular. So if you look at the position of Ka in both, so you have like a hex position of 73 for Akriti, whereas for Krutidev you have at a hex position of 64, the Ka character. So you can get from you are going to use this font. So in any say any application which is going to be designed for Qtdev font will not be able to probably use the Akriti font and vice versa. So just look at one example. So I'll explain what this is, right? So I wrote the characters DEY and I applied the Arial font. So that's what you see at the bottom most. Applied the Arial font, and it looks DEY. When I apply the Krutidev font, it shows me Kamal. And when I apply the same with Akriti font, it shows me Mabhat, whatever it is. So why I'm showing this, right? So why I'm showing this is to make you understand like what the developers for the applications needed to do. So what the developers for the applications needed to do was that they needed to like map in case they needed to show the Hindi in the Krutidev font, they needed to map the value of D to K and E to M and Y to L and so on and so forth as defined in that font. But now once they have designed that application, right, once they designed that application to support Qtdev font, if they wanted to use a different font which was not in the same layout, then they could not do it. They had to again redefine that to be able to use the other font. And in a single application, they could only have one definition, and which meant that it would only work with this with a single font. And what happened is that all the data which also got created, right, using using these fonts, was very specific to that. So if you wanted to even say convert that data to a different form, or like make any sense of that, it became difficult, because it was like, okay, data created, so Kamal in Akriti would get represented in some different say encoding, whereas in Kutidev it would be in some different encoding. So that created a bit of a problem, but that got solved by ISFOC. So this is one standard ISFOC layout. So I caught a glimpse of only a part of it. So ISFOC standardized the layouts for all Indian languages, and what it did there was it standardized the layout for using Indian languages alone, or using Indian languages with say English. So it's standardized for both monolingual fonts and bilingual fonts. So yeah, so continuing from there, so ISPOC standardized for all languages, and those were all defined within that 1 byte range. So they had practically about 190 characters to design for any font, and they standardized the layouts. What it helped was that one it solved the problem of uniformity and compatibility, and secondly, it also helped that the font designers could actually focus only on the design and the calligraphy. So they did not really need to worry about the layouts or what is going to be an optimal layout and stuff like that. They just focused on creating their own styles, basically on top of the layout which was already defined. So fonts based on ISFOC and also non-ISFOC fonts are quite widely used in the publishing medium. So now let's look at OpenType. So OpenType as a display standard was not limited to ASCII, and it could support all scripts from Unicode. So that was an upgrade. So what happened is now you could use multiple languages together, because OpenType could define for not just 1 byte characters, it could define for 2 byte characters, which opened up the possibility of using multiple languages in the same application. But what it did for the designers was that it introduced a lot of complexity. So OpenType fonts were a lot more complex than their ISFOC counterparts. The font designing was not only left to creating shapes, also the rules had to be included in the fonts, which made that most of the calligraphic designers became redundant. Also, OpenType fonts are complex because they have a lot more shapes as well, as compared to an ISFOC font, which would be limited to 190 shapes. And OpenType as a display standard ignored Indian language script properties, and OpenType was basically based on glyph properties and not the character properties, which was defined by ISCI, and subsequently this led to certain problems we'll see as we go along. So let's look at some display issues, and I'll come back to why OpenType contributes or why OpenType is limited in terms of handling this display issues. So if you look at this example, you could see like I took 2 examples, and one is from Hindi and the other one is from Bengali. So one is Devanagari script and the second is Bengali script, basically. So we can see that on the single character curve, we have 3 matras which have joined. And similarly on the Bengali example, on the single character per, we also have 3 matras which is joined. We obviously know this is wrong and this is not how it should behave, but why is it so? So let's just try and look at why we have these problems. So why these weird shapes, right? So OpenType display works on glyphs, and for just at a simplistic level, glyphs are basically the shapes which are seen in a font. So I'll just go back a few slides to just tell you what is a glyph. So if you look at this, each of this is a glyph. So each of these may not be a character as such, right? So there are half g forms, half k forms, half thr forms, and whatnot, and say conjunct forms also and and so on. So the all of these, each of these is a glyph basically. So it's a shape that a font designer creates to represent say a character or a part of a character. So yeah, coming back, so OpenType display works on glyphs and not characters. So OpenType segregates the glyphs as base, characters, and marks. So marks can join a base. So a single base can have up to 4 marks, like right, left, top, bottom, and hence you can have shapes like having 4 matras, and I put in some examples from other languages as well. Uh, so what should actually be the correct representation? So basically the correct representation should only have the consonant having a single matra, and the rest of the matras should be shown by the dotted circle, which is a consonant placeholder basically, and Vivek also touched upon during his presentation on the dotted circle. So this is how it should actually appear in case this sort of an input has come in. So another problem which OpenType creates is it also contributes to creation of different multiple forms of a single representation by rendering them as same. So if you remember the home example which we were seeing while seeing the search examples, now in both of those cases, it was actually being written with in two different ways, right? Where the first way was her followed by a o matra followed by ma, and the second was her followed by a matra, then a and a ma. So if you look at this open type also contributes in this sort of a issue. So now let's look at what we learned in school, right? So how we learned languages in school. So what we did was we first learned the Varnamala, so where we learned the swaras and then the vyanjans, and then we started learning the matras, and we know for which swar is what matra. Post that we started learning the Barakhari, so where we learned that each character can get joined by a matra, and we get the ka, ki, ku, kha, ki, ku, and stuff like that. And post that we started learning the yuktakshars, right? So that's how we learned our language. That okay, now finally we'll end up at the yuktakshars, where we learned a consonant can join a consonant, and it could join like it could be also go up to about 3 levels as well. So now let's look at how this learning can be used in computing. So actually for us to use this learning in computing, it was already defined by ISKI. So ISKI defined how the Indian language display systems and editing should work, and all these definitions were based on the principles of our languages itself. They didn't invent anything new. All they did was try to put those learnings in a very optimized manner so that it could be used for computing. So all the teachings or the philosophies which are being put forward in ISKI are actually based on how our languages are. And it's not that they invented something, it's just that they put it in a more easier manner for computing to adopt them. So ISKI defined the behavior for all the different characters as we know them basically, and also it defined how characters would behave when combined with each other. ISKI defines something called a script grammar. So this is a very important concept which ISKI defined. Vivek already touched upon this, and I'll just go on to just speak a bit on this as well. So it also defined that Indian language display system should be based on Indian language script properties, and which works on the character sequences and not really on glyph sequences. So if you think about the examples of these weird shapes, if we had looked at the character sequences rather than it as shapes and try to put it and display it, we would have had a different say display on all of them. So what are different character types of Indian languages? So we have our vowels, and we have our consonants, and we have our matras. Chandrabindu, Anusar, Visarg have been classified into something which we call as modifiers. And we have the consonant joiner, which is the halan. We have our numbers and numerals, and we have other symbols and punctuations such as Poon Viram and the Om symbol. So those are like the other symbols and punctuations. So now let's look at what got defined in script grammar, right? So basically what ISKI defined was that firstly it defined the concept of a display syllable. So what is a display syllable? A display syllable is the smallest unit which can be displayed independently. So it can be a single character or a combination of characters. So we'll come to that. We'll come to what are the valid display syllables. So right now, so if you look at it, so there are three types of valid display syllables. So one is the vowel syllable. So you can have a vowel and which can be followed by a modifier. You can all and then there is the consonant syllable where you can have consonant halant combinations, and then the consonant which can be optionally followed by matra and a modifier. So here when I'm talking about consonant, I'm referring to it as both consonant and or a consonant which is followed by a nukta. And if you look at the square braces, so anything which is enclosed in the square braces may or may not be present. So I've tried to put it in a simpler manner from how exactly it is written in the ISKI document. And apart from that, you will have your independent syllables, which will be your numbers and other signs and punctuation. However, there are certain exceptions which have crept into our languages, and some of these exceptions are just to be able to accommodate foreign words which are not native to our languages. Like in the case of Bengali, we see for words like application and app, we see that the can join a geo matra followed by a matra. So this goes against the rules of the script grammar. And in Tamil also it's pretty rare, but we do see that the use of the Tamil visarg in front of the per character to facilitate the pronunciation of fa. Although it is not used in any of the native Tamil words, it is a pretty commonplace use when people are trying to write foreign words or English words which have the pronunciation of verb. So staying on script grammar, so we'll just reiterate that. So what are the different sorts of vowel syllables it can produce? So the vowel syllables are like the single vowels or the vowels with the bindi, chandra bindu, and bindi, chandra bindu, and visarg. And the consonant syllables can be the single consonants with the matra. So we could have conjunct consonants also, and we could have conjunct consonants followed by matra. We could also have conjunct consonants which are followed by matra, and then we have a modifier as well. So what the script grammar also tells us is that a valid word can only be composed of a valid vowel or a consonant syllable. So it also tells us that a matra and a halant can only follow a consonant, right? So, and a modifier can only follow a vowel, a consonant, or a matra. So in case there is an independent matra, modifier, or halant, that has to be represented with the dotted circle. So the dotted circle basically represents an empty consonant. So if you look at this example, like if we have a sequence where ka is followed by e and a, then you must represent it as ka mein e matra as a single syllable, and the a matra with a dotted circle, which is another display unit. So basically here ka and e part become one display unit, and the a matra with the dotted circle becomes another display unit. So if you take your mind back to the home example, right? So the second way of writing, how it was written in the second way. So if the script grammar would have been followed, the display itself would have told that there is something wrong in it. What the display would have done is displayed it as ha, and then the A with a dotted circle, and then the ma, and instantly the person who was creating that content would have known that they've made certain mistakes. So we'll be talking a lot about script grammar and how to use this as a principle while defining or while doing any operations for Indian languages. And this script grammar philosophy can be used to create any sort of validation routines which you could use to validate whether a word is valid according to script grammar or not. So what happens is many a times while typing, and because we do not because the script grammar is not supported um, in the standards which are available today, what happens is many a time if you type something which is a top matra and all, people mistype by typing it twice, but it appears you will never get to know whether it's a mistype or not, and people will not know. You'll just see that matra font becoming a little darker. So for example, if you just type uh, a matra and then type it twice, basically type the a matra twice, you will not see it any differently. You will probably just see it a slightly shade darker, and people who are creating a lot of content are likely to make these sort of mistakes when they are typing very fast. So that is where a display system which is based on script grammar, which actually highlights these sort of issues, can help a lot. So yeah, that's about it, which I intended to cover till today. So be happy to take certain questions right now. So we'll be covering on editing and how to use script grammar for Indian language editing, and the basics on which Indian language input tools are to be built in our next session.
Great. So thank you, Pranjal. Are there any questions that we can take now? Uh, that was a pretty interesting session. Please type in your questions if there are any. So what we just learned today is a brief history about how Indian language implementation on computers they started. What were the thoughts behind and the considerations that made those things happen? It is very important for us to understand because the Indic script and their properties are significantly different from how English works. The scheme that was adopted eventually, which we use today in computing, uh, therefore is also determining how efficiently we will be able to implement our tools. Uh, Pranjal, let me read a question out for you. Miss the part of the session will get recordings of these sessions. Yes, there are session recordings that are available. You should be able to get them. Can script grammar be implemented open source, such as in Ubuntu? And has there been any efforts in doing the same? Um, e- I do not know if there has been any other efforts because most of the platforms today do not implement a proper script grammar at all, or there are no script grammars implemented in most cases. But we will be releasing these tools along with these sessions. The objective is to basically help programmers like you understand what it is and how to use them so that we can release and you can benefit from that. How difficult it is to create digital content, especially taking into account all this non-uniform encodings. That is Mahesh's question. Pranjal, would you like to answer that one?
Yeah, so Mahesh, there are so I today I covered only on the display aspects of it, and you saw the problems on the display aspects. But I also talked about something which is called normalization, right? And also in our next session we'll be covering on the input method, where I will be covering on how you should be using the input method and how ideal input method should be. So in today, whatever is existing, what you could probably do is basically use the basically write routines which can help you identify whatever got created, whether there were issues or not, you could basically use the script grammar to create routines and releasing certain tools, which would help you to validate or point you out to areas where there could have been issues in the data which got created. So hope that helps answer your point.
Yeah. So Mahesh, just to add to what Pranjal said, that digital content creation is not difficult, but uh, it is just that we have not really focused so much into creating the right kind of tools to create, consistent and good quality content. Whereas doing that for Indian languages is actually much easier than doing it for English. It is just that we haven't done enough. And I think with these sessions, we will be doing a lot of that. Many programmers would implement, and we will have such tools. Any other questions? Okay, I think I'm really thankful to the participants of today. This was the start. I believe that a lot of this information might initially appear not so relevant to what most of us are trying to do today. But trust me, uh, we at Reverie constantly use a lot of background knowledge about Indian languages or Indian scripts in computing. And we are trying to share uh, those in a sequence, which you will find quite useful as we go forward. So we really look forward to the next session when we will learn a lot more about input methods and so on. Uh, uh, there will be some very interesting quizzes, and if the quizzes that are common sense but can definitely be very intriguing, and we have a lot of goodies, Amazon vouchers and other prizes. Really look forward to having such sessions and interactions in the following weeks. Thank you, everyone.
Thank you, everyone.
Thank you.
Forward to the participation in the next sessions as well.
Thank you, Vivek. Thank you, Pranjal.